So consider this scenario. You're driving on a 300-kilometer road and it's a straight road. And for the first scenario, you're driving at 50 kilometers per hour and say the time taken is t1. In the second scenario, you're traveling at 75 kilometers per hour and the time taken is t2. And for the third case, you're traveling at 100 kilometers per hour and the time taken is t3. And for the sake of discussion, imagine you're traveling at a constant speed. What we do know is that there is a 25 kilometer increase from scenario 1 to 2 and from scenario 2 to 3. The question is, does the time saved to cover the same distance stay the same? Concretely, so from 50 to 75 we have a 25 kilometer increase, and from 75 to 100 we have a 25 kilometer increase. You could consider it a constant k. So for the same amount of time change, which is k, is the speed saved also the same? So is t1 minus t2 equal to t2 minus t3? So let's break it into its fundamental components. So speed is equal to distance by time, or in another way, time is equal to distance divided by speed. So we can calculate the time for 50, for 75, as well as for 100. So the time difference here of 6 hours and 4 hours is 2 hours. So fundamentally, if I am traveling at 75 kilometers per hour, I end up saving 2 hours of my travel. And similarly, when I am doing from 75 to 100, do I again save the same 2 hours? So what does happen is that you end up saving actually not 2, but instead 1 hour. So then why is it that for the same change in speed, the time saved is different? This got me thinking that for the relationship of a proportional increase in speed to have a proportional saving in time, that is only possible if there was a linear relationship between speed and time. Only then is it possible that a 25 kilometer increase would lead to a proportional saving of time. But the fact of the matter is, this is far from reality. So the thing is, there is actually a non-linear relationship between the speed and time. And because of this, there is, for a proportional increase in speed, there is lesser saving in terms of time. So the increase in speed yields diminishing returns in terms of the time saved. Somehow this particular way of thinking is fairly common, that linear relationships sound intuitive whereas non-linear relationships sounds counterintuitive. So in this episode, I just want to know why we think in straight lines. Well, in day-to-day life, thinking in straight lines makes sense. Consider the case that you are creating your own bookshelf and say each shelf can accommodate 3 books. So if you increase the shelf, you can accommodate 3 more books and 3 more, and so on and so forth. So this kind of relationship follows a straight line, and it makes sense that increasing the number of shelves means I will also increase the number of books that I can put on my shelf. Another easy to follow example is bank balances and their relationships to monthly savings and monthly withdrawals. Now let's take another example. Say you're a manager of a rental company and your job is to reduce the capital expenditures. And say you have got 2 fleets of cars. One is an SUV which gives a 10 miles per gallon and a sedan which gives 20 miles per gallon. And say for the sake of this example, there are equal numbers of those and each of those cars are traveling 10,000 miles a year. And to make it more interesting, say you have enough money to replace one model with a more fuel efficient one. And say these are the numbers. So the SUV, if you change it, you get a 10 miles per gallon increase in efficiency, whereas for the sedan, you get a 30 miles per gallon increase. So which will you replace, the SUV or the sedan? So if you chose the sedan, let's see if you actually ended up saving more fuel. So we know that gallons is equal to distance by miles per gallon. So using this as a formula, we find that for 20 mpg we get 500 gallons used, and for 50 mpg we get 200. So the difference, which is 300, is the gallons that we saved by changing the sedan. On the other hand, for the SUV, For 10 mpg you get 1000 gallons, and for 20 mpg you get 500. So the gallons saved is 500 in that sense. So that means if you had replaced the SUV, that is a better choice. This is counterintuitive, right? We went from 10 to 20, and that saved us more gallons or more fuel compared when we went from 20 to 50. This is interesting. The reason why this sedan is not the wiser choice here is because our minds are trying to form a linear relationship between miles per gallon and the gallons. Instead, the gallons versus MPG is a non-linear relationship where the fuel saved is disproportionately more when improving of low mileage cars. So even if the 20 to 50 MPG choice is larger, because of the disproportionate relationship between gallons and MPG, it proves to be the unwise choice here. Isn't that mind equal to blown? Non-linear relationships are everywhere, yet our minds often struggle to grasp them. They play a crucial role, especially in policy making. For example, a study on organic purchases showed something surprising. People overwhelmingly chose products with a 5-star environmental rating, but interest dropped sharply for anything less than 5-star. This means incremental improvements in ratings don't always lead to the more sustainable choices. Only the highest ratings make a real impact. Mortgages provide a clear example also of how nonlinear relationships can defy expectations. Many homeowners are surprised by how little progress they make in paying off their loans in the early years. This is because most of the initial payments go towards the interest, with only a small portion reducing the actual debt. In contrast, as the loan progresses, a large share of each payment goes towards the principal, leading to much faster reductions towards the end. This non-linear payoff often catches people off guard, especially when they sell a property early and realize how little equity they have built after factoring in costs like brokerage fees. So, if these examples were not enough, let me give you another example to drill the point home. So, suppose a company sells 100,000 water bottles each year at $2 per bottle. Producing these bottles costs 100,000. Now, the 50,000 in fixed costs and 50 cents per bottle in variable costs. So the per unit profit is $1. Now, if the company doubles its sales to 200,000 bottles, the fixed costs are spread across more bottles, increasing per unit profit to $1.25. That's a solid gain. But here's where it gets a little tricky. If the company doubles sales again to 400,000, the per unit profit rises much more modestly, and by the time they sell 800,000 bottles, the increase is only about 6 cents per bottle. So this happens because fixed costs become less significant as sales grow and variable costs remain constant. So the managers often overestimate the impact of the volume growth on profit due to the linear thinking. Instead, strategies like raising prices or reducing production costs can have a more significant impact on profitability. This particular example is one of my favorite ones. So many of us fall into the trap of linear thinking, which makes it hard to fully grasp the power of compounding wealth. So let's break it down. So when you save a fixed amount every month, your total savings grow steadily over time. And that's easy to understand, right? But compounding works differently. With compounding, your money grows not just from what you save, but also from the returns earned on the previous returns. And this creates an exponential curve that far outpaces linear growth over time. For example, like after 10 years, the compounded amount is significantly higher than that you saved, already showing the power of compounding, right? But by 30 years, the gap between the two is staggering. Yet our minds often fail to intuitively predict the exponential growth. It's why compounding is often called the eighth wonder of the world. And those who understand it benefit greatly, while those who don't miss out on its full potential. So you've reached this far, so let's ask the golden question. So how to get better at non-linear thinking? How to get really better at it? So Start by training yourself to recognize nonlinear systems. Examine relationships between variables like price and demand or speed and fuel consumption. So, if changes in one variable consistently lead to proportional changes in the other, it's likely linear. But if small changes in one variable starts causing disproportionate effects in the other, you're dealing with a nonlinear system, an area that requires a deeper analysis. Next, familiarize yourself with different types of nonlinear relationships. So, each tells a unique story. So, quadratic growth accelerates and then slows, exponential growth explodes rapidly, logarithmic growth flattens over time, and sinusoidal patterns oscillate in waves, capturing cycles like seasons or market trends. Recognizing these patterns help you decode complex systems in areas like business, natural phenomena, or even daily life. Finally, always seek more data points. Conclusions drawn from just 2 or 3 data points can be misleading. What looks linear initially might reveal exponential or other complex patterns with more data. So, the more points provide more clarity and a deeper understanding of how systems truly behave. Wow, you've made it this far. Thanks so much for watching my content. If you do like it, please like and subscribe, it will help me a lot. Catch you guys in the next.